Based on the graph, I tabulate the conduction range and the conduction angle of each thyristor in this table. For waveform analysis, we will focus on the average and RMS output voltages, ripple factor, and rectification ratio of the rectifiers. As usual, I will start with the waveforms and equations of a single-phase uncontrolled half-wave rectifier with resistive load. Now, I will change the waveforms based on the operation of a controlled rectifier. Based on the new output voltage waveform, the voltage equations will change as follows. As we can see, the integral range has changed the starting angle from 0 to alpha. Next, let's compare these voltage equations to the voltage equation of uncontrolled rectifier. From both equations, we can see that the firing angle has caused the average and RMS output voltages of the control rectifiers lower than the uncontrolled rectifier. Thus, these equations have verified the function of controlled rectifiers. Lastly, I will compare the ripple factor and the rectification ratio of both rectifiers. The left side is referring to the control rectifier, while the right side is referring to the uncontrolled rectifier. By considering Vm equal to 1 volt and alpha equal to 30 degrees, we can see that the control rectifier has lower performance than the uncontrolled rectifier due to the firing angle. Based on this information, we can conclude that the firing angle is inversely proportional to the average and RMS output voltages and also the performance of control rectifiers. Lastly, I will show the differences in terms of waveforms and equations between uncontrolled full wave rectifier with controlled full wave rectifier supplying resistive load. I will end this video with this example question. Based on the statement, we need to use this information to find the ripple factor, the input power factor, and the control signal if the rectifier uses IGBT as the power switch. First, I will focus on the ripple factor. From this equation, the only parameter that we do not know is the RMS output voltage. And you can calculate the voltage value using this general equation. However, to solve this equation, you need to find the firing angle. And the angle can be found using the average output voltage equation. From this equation, the firing angle is equal to 39 degrees. And by using this angle value, then you can have the ripple factor equal to this percentage. Next, you can use this equation to find the input power factor. And lastly, for the control signal, we need to consider the transistor operation. Unlike thyristors that require a short control pulse to turn on, IGBTs require continuous control signal to turn on. Hence, the answer for this question is as follows. That's all from me. I'll see you again in the next video.